When puffins get too cold, it is the heat conservation center of the hypothalamus which is stimulated. The primary way for increasing heat production for puffins is vasoconstriction. Another way for increasing heat production for puffins is shivering. The large flight muscles, or pectorals, as well as the leg muscles play an important role in generating heat by shivering. Shivering is a randomized quivering of muscles and can produce heat at a rate 5 times greater than the basal metabolic rate. It is a puffin's first line of defense against decrease in temperature. Shivering occurs when temperature receptors in the skin and brain sense a decrease in body temperature and trigger the shivering response. Muscle groups around the vital organs begin to shake in small amounts in an attempt to create warmth by expending energy. When puffins get too hot, the heat loss center in the hypothalamus is stimulated. The relatively high deep body heat temperature, the absence of sweat glands, and the localized distribution of fat, and the effective insulation provided by feathers distinguish the thermoregulatory physiology of birds from other groups of homeothermic animals. Birds depend heavily on panting as a thermoregulatory mechanism in hot environments. Puffins have no sweat glands, so evaporation, one way to lose heat, can occur only by the respiratory system. If a puffin was exposed to a high surrounding of temperature, the resulting hypothermia would cause the puffin to pant. With increasing body temperature, the respiration rate increases. The respiratory system of the puffin bird consists of the lungs and the air passages leading to and from them. The air passages are made up of nasal cavities, trachea, pharynx, and bronchi. A warmer climate or exercise will give a puffin a rapid respiration rate. Regular breathing would allow greater heat dissipation. If the body becomes too hot, the body sends signals to dilate the blood vessels, which is called vasodilation. This expansion of blood vessels brings the vessels closer to the skin surface, allowing heat to escape more easily. If this isn't enough to cool the body, panting will occur and increased convection and evaporation from the air sacs will occur, helping lower the body temperature. Oil spilled by tankers and drilling operations can cause the puffins to become sick when they swallow oil while attempting to clean their feathers. The toxins, such as heavy metals found in the oil spills, can scramble the electrical signals that reach the hypothalamus, causing it to release powerful hormones that affect the autonomic nervous system, therefore affecting the ability for the hypothalamus to send the right signals in order for the feedback loop to function properly. Positive feedback is a cycle in which one change leads to even more significant changes in the same direction. Positive feedback is a way for the body to produce significant changes in a relatively short period of time. Positive feedback isn't always beneficial to the body. If an infection is present, the body may respond with an increase in temperature or fever. If the infection continues to spread and develop, the body may continue to raise its temperature in an attempt to rid itself of the infection. If the temperature rises too high, it can have serious and even deadly consequences. If the positive feedback loop continues, death is likely to occur. The adaptive significance of having thermoregulation is that puffin birds have the ability to live in a cold environment where there are very few predators in order to get food efficiently throughout the year. Endothermy allows puffins to stabilize their internal temperature in a cold environment, allowing biochemical processes and nervous system functions to reset at steady high levels of activity. Therefore, they can remain active in winter and exploit habitat denied to ectotherms. This gives them a greater chance of survival. During the day, puffin birds are very active. They have long migration routes and work hard to catch their prey. The panting mechanism keeps them active by alleviating heat exhaustion. Thank you for watching.